Hello guys and welcome back to Current Technologies. I'm Michael and you are watching the complete Android Development Diploma for Beginners. In today's video, we will have code examples for data types and typecasting. As we said before, we have primitive and non-primitive data types in Java. Let's begin with primitive data types. I will show you all the possible values that can be stored in each one of them. For that purpose, I created here a new Java class called data types. And here inside the main method, we will start with data types that stores integer numbers, which are byte, short, int, and long. They vary from one another according to the numbers range that can be stored in each one of them. Let's see this in code. So here inside the main method, let's begin with the smallest one of them, which is byte. I will call it B1. Let's store here the smallest value or the minimum value that can be stored in byte variable, which is -128. Because as you remember, byte is the smallest one. Another byte variable, I will call it B2. And we will save the maximum value, which is 127. All numbers in between these two integers can be stored in byte, but not less than -128 and not bigger than 127. If we try to make this -129, it will give us an error. The same here if we try to make it, for example, 129 or 128, still gives us an error. But if it's 122, it's okay. 126, it's okay. Maximum is 127. Okay, let's move on to the next data type, the bigger one, which is short. Call it SH1. And again, the minimum value for short is -32768. Another short variable, sh2, equal, let's store the maximum value, which is again 32767. If we try to make it 769, again error. So this is the minimum value and maximum value that can be stored in short variable. The next one, which is the bigger one from byte and short, the integer variable or the integer data type. Let's call it in1. The minimum value that can be stored in integer, it's a very big number, which is like more than 2 billion. So I will just copy paste from here. This is the minimum value that can be stored in integer value. More than 2 billion, sorry. Let's go for the maximum value that can be stored in integer. Copy, paste, this one. This very big number, which is more than 2 billion, is the maximum value that can be stored in integer. Last data type that can store integer number is long. Long is the biggest one of all of them, bigger than byte, short, and integer. Let's call L1. Here we will try to store the minimum value that can be stored in long variable, which is again this very big number. I will just copy paste again. Oh, sorry. Here, very important notice, in long variable, you should add, at the end of the value, you should add L letter. Again, another variable, long variable, L2. Stores the maximum value that can be stored in maximum value that can be stored in a long variable. Here, this maybe it's 8. Yeah. So these variables now store minimum and maximum for each data type. Now, using which one of these, it depends on the requirement and it depends on programmer's estimation. Like, for example, if you want a variable to store age of person, we can use byte. I don't think a person can live more than 127 years. But if you need a variable, for example, to store years, like for example, at the time of recording this video, we are in 2022. So if you want to store a year, maybe you can use short, which has maximum value of 32,000 of number. Again, the integer value, which gives you a range more than 2 billion, you can use it if you are counting a population of a country. Finally, long, which is the very huge range, the biggest one of them. Maybe you can use it for calculating fortune of the richest men in the world, maybe. I don't think you really need long too much while coding. Probably, or most of the time, you will see integer. Like it's a default data type that is used to store integer numbers. But it all depends on you as a programmer and it depends on your requirements. Let's move on to another data type, which is Boolean. If you remember Boolean, it's the smallest primitive data type ever. Its size is only 1 bit, which can store only a true value or a false value. Yeah, here we have to be 1, so it's a good notice. This variable name cannot be duplicated, so we change the name. Here, the first possibility to be stored in Boolean variable is true. Another one is to make it false. There is no other possibility for Boolean variable. What's next is char. Char is used to save a single character inside. So I call it, for example, C1. This value should be inside a single quote like this. Okay. And this value could be, for example, a letter. Could be a number and could be also a special character. And don't forget to change the variable names here. Next, we have two data types that is used to store decimal numbers. We have float. One. Float data type allows us to store up to 7 decimal point number inside. So, and again, float is the same as long. At the end of the value, you should add F letter. The bigger data type than float that is used also to save decimal numbers is double. Double. Create a variable of double data type, call it D1, and then it allows me to store up to 15 decimal point number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And don't forget D to add the letter at the end of the value. So this is all the data types that we have: byte, short, int, long, Boolean, char, float, and double. This is the primitive data types. There is one important, very important, and very commonly used non-primitive data type that I want to show you here, which is string. String data type is a non-primitive data type, which is a class that is used as a data type to store text values in Java. So I call this one string. Okay. Any value that is stored in a string should be written inside a double quote like this. Values that can be stored in a string can be letters, can be numbers, and also can include special characters. Yes, don't forget the semicolon. All these data types, it's all up to you how to use them and when to use them. So before we move on to the next point, I want to show you something. When initializing a variable, I create int x equal 10, for example. If I create another integer variable called y, I can store x value inside y. So I don't have to every time give a hard code value like this. I can store a value of a variable into or inside another variable. This will lead us to discuss about the typecasting. Here I did it very easy because both of variables are from the same data type. This x is integer and y is also integer. But what if I have two variables of different data types and I want to assign the value of this variable to this variable? What I'm gonna do, this is called a typecasting in Java. As we said in the last video, typecasting is converting a data type to another data type. Okay? Mainly in Java, we have two types of typecasting: a widening typecasting and narrowing typecasting. Let's go into the code and see both of them. For that, I will create a new class, Java class. I call it typecasting. Let's add the main method here. For example, we just said that short data type is smaller than integer data type. So here let's create a short variable and I will give it this value. What if I create another variable which is of integer data type? I call it I, and I want to store inside the short variable. Is it a problem? It's not giving me any problem. Let's try to print the value inside I here. Let's run this program. It's giving me 125. There is no problem. Why there is no problem? Because I'm storing a variable of short data type, which is smaller than integer data type. Here, the I of integer is bigger than short. So here, this is called widening typecasting. I'm trying to convert a variable of a smaller data type into a variable of a bigger data type. I'm trying to typecasting short to integer. So this is very easy and it's done automatically without any problem. What if I want to do the opposite? I have, for example, integer x and it has value of 150. Okay, and I want to typecast this x into a short variable. Short, I call it s. And here I give it the value of x. What will happen? It will give me an error. Why? Because integer is bigger than short. So here I should make a manual typecasting, which is done like this. Between brackets, I call it short. Here the error is gone. Again, if I try to print the value of s, let's see what will happen. Yeah, it's 150. It's working just fine. So this type of typecasting is called narrowing typecasting, which should be done manually this way. Okay, let's have another example of typecasting. What if I have char? I call it C. Okay, and the value inside this character data type is C. So I store the C letter inside a C variable. After that, I create integer variable called y. What if I tried to store C inside y? What will happen? I'm telling you it's gonna work. So here, if I try to print the value of y, it will give me a number, which is the ASCII code of C letter. Let's run and try. Yes, it's giving me 99. If I go to ASCII table, like here, this is ASCII table. I have a list of characters, all characters, and each character there is a decimal number representing that character. So if I go to C letter, okay, it's represented in decimal by 99. And when I run my code, I get the output of 99 number. So this is all for typecasting. If you find this video helpful, please like and share. Also subscribe to our channel for more interesting videos to come. Don't forget to follow us on social media like Facebook and Twitter. And if you have any questions or if you want to be in touch with me and with other students, you are welcome to join our students community on Facebook. I will leave all the links in the video description box down below. See you in the next video and happy coding.